Welcome everybody. Today we're going to talk about tangential velocity, which is the instantaneous velocity for an object that's moving along a curved path like the one that I have drawn here. To figure out what the tangential velocity is doing, we're going to use the definition of the instantaneous velocity, which is as the derivative of position with respect to time. And as we know from calculus, we can write a derivative as the limit as delta t goes to 0 of this ratio between the change in position and the change in time. To do that, I'm going to draw some vectors on my picture here. Here's the position of the object as it goes along the path. To find this change in position, I'm going to need to pick two different points, pick an origin of coordinates, and then draw some position vectors. So here would be my initial position vector, and here would be my final position vector. And then this definition is telling me to find the difference, the change in the position, which is the vector that points from the initial position to the final position. And so it will look something like that. And then to get the direction of the velocity, I would divide by delta t. Delta t is a positive quantity, so no matter what, I'm going to get a velocity vector, an average velocity here, that points in that direction. The last thing this definition tells me to do is take a limit, which means what I need to do is imagine drawing these points closer and closer together. So here I might have an r f prime, which would give me a change in velocity, or a change in position rather, that points that way, and therefore an instantaneous velocity that points that way. And then I can do it again, picking these points to lie closer and closer together. At the end, if I sort of blow that picture up and I've picked two vectors that are nearly pointing to the same location, I'm going to get a really tiny dr change in position vector. When I divide that by dt, it doesn't change direction. So this, which is the limit of these vectors, is going to be the direction of my tangential velocity. And I've chosen this name intentionally because what happens here is this velocity will always point tangent to the curve, to the path that the object is moving along.